epicyclic gear train, right? So when we study the different types of gear trains, right, we have studied a type that is epicyclic gear train. So in shape that will be like this, right? We will have a gear externally, we will have a gear internally, right? So these gears would be running on this gear, right, the big gear. Okay, so a rotation made by this will rotate this gear as well as this gear, right? We'll see what how does it work. Epicyclic means one gear revolving upon and around another, right? One gear revolving upon and around another, right? So the one would be rotating as well as it would be rotating another one also, right? Revolving upon and around, right? So we have two words, upon and around another. The design involves planet and sun gears as one orbits the other like a planet around the sun. So these are called as planet and sun, sun and planet gear also, right? So this is more or like less kind of. So if you consider this as the sun and this as the other planets, right? So when this rotates, this one will also rotate, right? So this looks like a planet rotating around the sun. Okay, so this is why they are called as in sun and planet gear also, right? Design involves planet and sun gears, right? Planet and sun gears as one orbits the other like a planet around the sun, right? So since they are working in a manner that as like a planet rotating around the sun, the name is gear. A small gear at the center called as sun. So this is called as the sun, you know, right? In the solar system, the which is sun is in the middle. So here is the sun. Several medium-sized gears called the planets and a large external gear called the ring gear. So these small gears, they are called as planets. So in the solar system, sun would be in the middle. Then we will have the planets around the sun. Similar way here also. So this would be the sun. These would be the planets. And the external gear is called as the ring gear. So this one, the big one, this is called as the ring gear, right? So if you consider this as sun, we will have like different planets, right? Mercury, then Venus, then Mars, then Earth, Uranus, Neptune, Pluto. This will go like, right? So sun, that is in the middle. Okay, you compare this and this. Sun, which is in the middle. And planets, these all are planets, right? Mercury, Venus, Earth, Mars, these all are planets. So here also these are planets. These are planets. They are rotating around the sun. So here also you see planets, they rotate around the sun, right? And the outermost, this gear is called as the ring gear, right? Ring gear. So these planets, they need a path to rotate, right? They can't like arbitrarily move here and there. So this ring gear, this hold the complete system, right? Advantages of epicyclic gear train. Now we'll see the advantages. They have higher gear ratios. They are popular for automatic transmissions in automobiles, right? So if you see, they are compact in size, right? So automatic transmissions are easy in use. They are also used in bicycles for controlling power of pedaling automatically or manually. They are also used for power transmission between internal combustion engine and an electric motor. So we'll see how these things are achieved when we go down to the other slides. So this is the kind of simple working model of a epicyclic gear train. Okay, simple working model. In an epicyclic gear train, the axis of the shafts over which the gears are mounted may move related to a fixed axis, right? So this is a kind of fixed axis you see here. This is a fixed axis. But here there is an arm connected between A and B, right? Between the gear A and the B, there's arm C is connected, right? Axis of the shafts over which the gears are mounted, right? Axis of the shafts on which the gears are mounted may move relative to a fixed axis. So these can move related to a fixed axis. Either A can move or B can move, or sometimes C can move, right? They can move related to a fixed axis. A simple epicyclic gear train is shown here, right? So this is a simple epicyclic gear train. Gear A and arm C have a common axis at O, right? So we know this is arm C and this is gear A. They have common axis O1, about which they can rotate. So if A won't rotate, that will rotate based on this O1. If C is rotating this arm C, then that will be rotating based on this O2, right? Not O2, sorry, O1. So this is how this gear A is going to rotate. And if the arm is rotating, so that's going to rotate like this, right? That's going to make a rotation like this. So based on O1, the arm can also rotate. Common axis O1 about which they can rotate. The gear B meshes with gear A. Gear B, it is meshed with gear A and has its axis on the arm at O2. So here gear B has the axis at O2. This is O2, about which the gear B can rotate, right? So when this arm rotates this way, right, on this axis, what do you think of this B? This B will rotate itself and it will rotate like this, right? Can you imagine? So when this arm go by this way, gear B, that will automatically rotate itself, and also this will also need to move around like this. So exactly as like a planet, right? Because you know Earth is rotating by itself and revolving around the sun. So this gear B, this is going to rotate by itself. I mean, yeah, rotate by on axis, and about this axis, this gear B is also going to move like this as a planet around the sun, right? So B measures with gear A and has its axis on the O2. So B will rotate around its own axis and revolve around this setup, having O1 as the axis about which the gear B can rotate. Okay, so having this as the axis, this can rotate like this if the arm is rotating, right? If the arm is not rotating, then B will rotate only on its own axis. If the arm is fixed, right? So here the arm is rotating. Okay, if the arm is fixed, so this is another condition. So now this arm is not going to rotate, and this is fixed. The gear train is simple and gear A can drive gear B. So if this is not rotating, what do you think? This will rotate this way, which means the B will rotate this way as like the simple gears, right? Because this C does not have any work now. If this is rotating this way, this will be rotating this way. If A is rotating the anti-clockwise, B will be rotating clockwise, right? So if the arm is fixed, the gear train is simple, right? This will change as a simple gear train. Why? Only one gear on the one axis, or vice versa. So either B can rotate A, B can be the driver and A can be the driven, or other way also, either A can be the driver and B can be the driven. But if gear A is fixed and the arm is rotated about the axis of gear A, then the gear B is forced to rotate upon and around the gear A. So now the third condition. So here is arm is fixed, but here if gear A is fixed, okay. So now if we fix this one, right? If we fix gear A, so now this is not going to move. A is not going to move. This is going to stay like this, and the arm is rotated about the axis of gear A. So if this is not rotating, the arm has to rotate this way, right? So based on O2, based on O1, this O2 point, this is going to come like this, right? This is how the O2 is going to move, because A is not rotating. So in that case, the B is also forced to rotate. So that will rotate by its own axis O2 and will also rotate this one, right? So that's what mentioned here. Then the gear B is forced to rotate upon and around. So rotating upon is this movement, Rotating around is this movement. Okay. Such a motion is called epicyclic, and the gear trains arranged in such a manner that one or more of their members move upon and around another member are known as epicyclic gear trains, right? So this kind of motion is called as the epicyclic gear trains, right? More than one gear moves upon or around the other gear. Such motion is the epicyclic, and the gear trains arranged in such a manner that one or more of their members, right? So one or more of their members move upon and on around another member, right? This epi means upon and cyclic means around, right? So this word epi is upon. Upon is on its own axis, and cyclic is around. So that is axis on the another system, right? So this is rotating mean the axis is here. This is rotating mean the axis is here. So this is upon and this is around. The epicyclic gear trains may be simple or compound. So it can either be compound gear train or simple gear train, right? Epicyclic can be either be simple or compound. So simple, we know there would be one gear at a shaft. Compound, we know there will be more than one gear at a shaft, right? So either they can be simple or they can be compound, the epicyclic gear trains. Velocity ratio of a epicyclic gear train, right? Velocity ratio of epicyclic gear train is the ratio of the speed of the driver to the speed of the driven or follower. So as like all the other gears, this velocity ratio is simple: speed of the driver to the speed of the driven, right? That's all simple. So in order to find this velocity ratio, usually in epicyclic gear trains, we'll use two methods, right? One is called as tabular method and the other one is called as algebraic method. The following two methods may be used for finding out the velocity ratio of an epicyclic gear train, right? So tabular method and algebraic method can be used to find the velocity ratio of an epicyclic gear train. We'll see one by one. So first one is the tabular method. So this is a normal picture, right? So based on this, we are going to do how we are going to analyze how to do that. Say for example, TA is a number of teeth on gear A, right? So gear A has TA number of teeth. TB number of teeth on gear B, right? TB, that is number of teeth on gear B. Suppose that the arm is fixed. So here we will assume the arm C is fixed, right? So arm can't move now. So this is fixed. Therefore, the axis of both the gears are also fixed relative to each other. So if the arm can't move, if this one can't move, what will happen? This A and B need to rotate only on this axis, right? This is not going to move, right? So if A is rotating this way, right? If A is rotating this way, B needs to rotate this way, right? And vice versa. So this is more like a kind of simple gear since the arm is not rotating. So we'll now see arm is fixed. Therefore, the axis of both the gears are also fixed relative to each other. So this axis is fixed, this axis is fixed. So now this is going to rotate based on this axis, and this is going to rotate on this axis. When the gear A makes one revolution anticlockwise, when the gear A makes one revolution anticlockwise like this, right? One revolution, the gear B will make TA by TA revolution clockwise. So we'll see how is that. So if this rotates at anti-clockwise, this will rotate in the clockwise. That's definitely everyone know, right? And we know speed ratio is NB by NA is equal to TA by TB, right? So speed ratio will be given by inverse of number of teeth, as you know. So NB upon NA, that is speed of NB upon speed of A equal to TA upon TB, right? So 2 teeth at A upon teeth at B. Here number of speed at B and speed of A. Here given is when the gear A makes one revolution, right? So instead of NA, I'm going to put now 1, right? Why? That's how it's given, right? So if the gear A makes one revolution, So now my equation is going to be NB upon 1 is equal to TA upon TB. Okay, NB upon 1 is equal to TA upon TB. So that is equal to NB is equal to TA upon TB. Since N is equal to 1, right? Right? This is 1. So NB is equal to TA upon TB, right? So speed of gear B is equal to TA upon TB. So that's what mentioned by when the gear A makes 1 revolution anti-clockwise, the gear B will make TA by TB revolution clockwise, right? TA by TB revolution clockwise. Okay, so that's this revolution TA by TB revolution clockwise. Assuming the anti-clockwise rotation as positive and clockwise as negative. So when we put in the tabular method, if we consider clockwise motion as positive, then we should consider anti-clockwise motion as negative. Or if you consider clockwise as negative, then you should consider anti-clockwise as positive. This is a must rule in the tabular method, right? So that's what mentioned here. Assuming the anti-clockwise rotation as positive. So if you assume anti-clockwise rotation this as positive, then you should consider the clockwise motion as negative, right? So this is a must rule, right, in tabular method. All right. Now we'll see how to put this data into the table, right? So this part is clear, right? If this is making a clockwise rotation, this will definitely make an anti-clockwise rotation. First thing, if the NB upon NA is equal to TA upon TB, and if NA is making only 1 revolution, then you will have NB is equal to TA upon TB, right? Now we'll see how to put them in the equation, right? So this is a table. Conditions of motion. We'll specify the conditions and then we'll put it in the table. Arm fixed, gear A rotates through +1 revolution. Okay, arm is fixed, so the condition is arm is fixed, right? So no movement for arm. Gear A rotates through 1 revolution, that is 1 revolution anti-clockwise. So it is given 1 revolution anti-clockwise. So gear A is making a 1 revolution anti-clockwise. So now it is obvious the gear B is going to make a clockwise revolution. So if A is making 1 revolution anti-clockwise, right, then B will have TA by TB revolution clockwise, right? That's what we have seen in the last slide, right? So if A is making 1 revolution anti-clockwise, okay, then A is making, sorry, B is making TA by TB revolution in the clockwise, right? So you see here, okay, if A is making 1 revolution anti-clockwise, B is making clockwise TA by TB, right? So since clockwise is considered as positive, I will put anti-clockwise as negative, right? This is again a must rule. So if clockwise is considered as positive, then anti-clockwise is considered as negative, right? Or you can consider other way also. You can consider clockwise as negative and anti-clockwise as positive. That's your idea. But if one is positive, the other one is negative, right? So based on our equation, I will have NA upon NB is equal to TB upon TA. And again, if the NA is equal to 1, right? Fixed gear OA rotates at 1 revolution. So this is now going to be equal to 1. So 1 upon NB is equal to TB upon TA. NB is equal to TA upon TB, right? NB is equal to TA upon TB. So when NA makes 1 revolution, NB is making TB upon, sorry, TA upon TB, right? TA upon TB. So what will happen if A is making a X revolution? Okay. So arm fixed A rotates through 1 revolution. B is at TA upon TB. anti-clockwise, so there's a minus. That's here. Okay. Arm fixed, gear A rotates through plus X revolution. Here that was 1 revolution. Now it is X revolution. So what we will do, we will simply multiply these entire values by X, right? So here I have 0 multiplied by plus X. We will not have anything against 0. Here plus 1, right? This is plus 1 revolution, but here that is X. So I will multiply it by X. So plus 1 into plus X, that is plus X. For 1 revolution, I have TA upon TB revolutions, that is for gear B. So I will now multiply this one with X. So I will have minus into X into TA by TB, right? So here, this is for 1 revolution condition, this is for X revolution condition. Now, this arm, assume, is going to move, right? So here we stop the arm and put the values for A, right? Now arm is also going to move. Add plus Y revolutions to all elements. Why? Because arm is going to move mean this arm is going to move, this B is going to move, A is also going to move, right? So I will add plus Y for all elements. So I will add plus Y here, plus Y here, plus Y here. This plus Y is the movement of the arm, right? So total motion. So here, if you carefully observe, arm fixed gear A, right? So here arm is fixed, gear A and gear B are moving, right? Here arm is also moving. So already gear A and gear B are moving. We stop the arm. Now on this row, arm is also moving, which means A is moving, B is moving, arm is also moving. All right. So now everything is moving. So I will add plus Y to all 3 columns. At the end, we are going to have the total of this. So here, if you see Y plus 0, that is plus Y. Okay. Here, when arm was not rotating, only A was rotating, that is X rotation. Now arm is also rotating, that is Y rotation. So here we will add X plus Y, right? X is the movement of A and Y is the movement of arm, totally X plus Y. On this gear B, if the arm is not rotating and if the gear is only rotating, I had X into TA by TB minus, because this is the opposite direction, right? So this is without arm moving. Here when you add this one, now arm is also moving, B is also moving, right? So we will add these two, plus Y, right? Plus Y minus X into TA by TB minus X into TA by TB, right? So the total motion, the motion of B is given by Y, that is moment of arm, minus X into TA by TB, right? So this X is the rotation of A into TA by TB, that is speed ratio. All right. This is what called as the tabular method. Any doubt in this? So here you need to visualize how A is moving, how B is moving, how the arm is moving. You need to imagine. So this is a kind of relative motion. So we are stopping one by one, and at the end we are adding everything. So here at the start we stop this C in order to fix this A and B's movement. So when we find the A and B's movement, I have C and adding the movement of C also, right? So now everything is moving. So this is a kind of relative motion, right? We will go to the other method, that is algebraic method. Okay. Right. So this is a kind of direct application of this relative velocity. Yeah. So you need to have like little bit of concentration on the relative velocity. We'll see. This algebraic method, the motion of each element of the epicyclic train relative to the arm is set down in the form of equation. So each element, A is an element, B is an element, and arm is an element. So each element we are going to set down in the form of equations. The number of equations depends upon the number of elements in the gear train, right? Let the arm C be fixed in an epicyclic gear train as shown in the figure. So now we are going to do as like what we have done in the tabular method. Now we are going to fix the arm C, right? So now only A and B are going to move. Therefore, speed of the gear A relative to the arm C, right? Speed of gear A relative to arm C, which means we are going to stop C and only A is going to move. So if you remember the relative velocity, right? If this is the velocity of A, right? And if this is the velocity of C, in order to find the velocity of A with respect to C, what do? We apply an opposite same velocity to C and to A, right? So opposite same velocity to C means now C is going to be 0, right? If C has a velocity this way and applying same velocity C this way, the velocity of C is going to be 0. So here also I will apply the same C to this A. So now A has a velocity VA this way, right? And velocity C is acting on the opposite direction. So that will be subtracted. So at the end, what will I have? VA minus VC. So relative velocity of A with respect to C will be given by VA minus VC, right? This you already know. So same formula or idea we are going to apply here also, right? Speed of the gear A relative to arm C, right? So which means I'm going to stop the arm and I'm going to leave the A to move. So that is BAC. Here I have NAC relative to arm C. What's the moment of A? That is NA minus NC. You see here VA minus VC. Similarly, speed of A minus speed of arm, right? So this is the speed of gear A relative to arm C, right? You need to look carefully into the sentence. This is relative to C. So which means you are stopping the C and allowing the A to move, right? Then again, speed of the gear B relative to arm C, right? So now this B relative to arm C, right? So that is NB minus NC, right? Velocity of B minus arm. Since this is relative velocity, that is NB minus NC, right? So this is the speed of gear B relative to arm C. So now I have found speed of gear A relative to arm B, arm C, and speed of gear B, B relative to arm C. All right. So I have two equations now. Now we will put them over here in the equation. Since the gears A and B are meshing directly, therefore they will revolve in opposite directions, right? So you see here, they are meshing directly. So if A rotates this way, anti-clockwise, you know B will rotate in the clockwise, right? That is obvious. Since this is making a kind of form of a simple gear train, if this is moving clockwise, definitely this will move in anti-clockwise, right? This we know. So since the gears A and B are meshing directly, therefore they will revolve in opposite directions, right? B and G are going to rotate in the opposite directions. Speed ratio we know can be given by NB upon NA is equal to TA upon TB, right? So if I apply this equation and this equation in the speed ratio equation, that is NB upon NC upon NA upon NC, NA minus NC, sorry, NB minus NC upon NA minus NC is equal to TA upon TB, right? Why? It is given the C is fixed, right? Let the arm C be fixed. So if the C is fixed, I can put 0 for C, right? There is no speed for C. So instead of C, I can put 0 here. Here also I can put 0. So that is NB minus NC, that is 0, upon NA minus NC, that is equal to 0. So NB minus 0 upon NA minus 0, that is equal to NB upon NA, right? That is NB upon NA will be equal to TA upon TB, TA upon TB. So this we know, this is our usual speed ratio equation, right? NB upon NA is equal to TA upon TB. This is our normal speed ratio equation. If the gear A is fixed, then NA is equal to 0. Now we are going to fix NA, right? NA. NC is already fixed, right? Now we are going to fix NA also. So if I fix NA here, this NA is going to be 0, right? But here now we are not talking about NC is fixed. Okay. If NC is fixed, then this is a condition. So this is the standard formula, right? NB minus NC upon NA minus NC equal to TA upon TB. If I fix NC, right? If I fix YARM, I will put 0 here to NC. And the equation will become NB upon NA is equal to TA upon TB. Right? If I leave the C to move and if I fix only A to 0, what will I do? I will put A is equal to 0 here. Right? A is equal to 0 here. But C, that will move right now because C, I did not say that is fixed. So when this A is fixed and C is moving, this equation is going to come like this. NB minus NC, that will be like this. NA, I said now is fixed, right? NA is fixed. So it means NA, here it was NA. Now it is fixed, that is 0. Okay, so NA is fixed, that is 0. So this equation will reduce to NB minus NC upon 0 minus NC. Why? NA is equal to 0. 0 minus NC is equal to minus TA upon TB, right? TA upon TB. So this you can solve like NB upon NC. Here NC upon NC, that is 1, right? So NB upon NC is equal to 1 plus TA by TB, right? You can make NB by NC as the subject, right? So here I will have minus NB upon NC. If I take it this side, I will have NB upon NC. Here I have TA upon TB. I will take it here. So TA upon TB plus 1, right? So 1 plus TA upon TB. So if NA is fixed, then this is going to be the equation. If NC is fixed, then this is going to be the equation. Say for example, you fix the NB, right? If you fix the NB, then NB will be equal to 0, right? So in that case, what will happen? Instead of NB, I will put 0. NC would be like that, and minus NC. Then at the bottom, I have NA minus NC. So there is no change on that, right? Only NA is fixed for NA minus NC equal to, this will be TA by TB. That will be fine, right? TA by TB, that will be like that. So from this, you can have NA minus NC by, and this way TB, right? And then if you solve, so I will take TB upon TA equal to, right? I'm taking it upside down. NA minus NC upon minus NC, right? So here TB upon TA is equal to minus NA upon NC plus 1, right? So you can have 1 minus NA upon NC equal to TB by TA, right? TB by TA. So minus NC upon minus NC, that is 1. NA upon minus NC, NA upon minus NC. So 1 minus NA by NC is equal to TB upon TA. So this will be the equation when B is fixed, right? So when B is fixed, right? So this is the equation when C is fixed. This is the equation when A is fixed, right? So this is your base equation, and from this you can fix whatever the link you wish, and you can move to the numerical, right? So NB minus NC upon NA minus NC equal to TA upon TB, and this is a base equation. And this is how we do the algebraic method, right? An epicyclic gear train, an arm carries 2 gears A and B, right? So epicyclic gear train arm carries 2 gears A and B, having 36 and 45 teeth respectively. So A has 36 and B has 45 teeth respectively. if the arm rotates at 150 rpm. So if the arm rotates at 150 rpm in the anti-clockwise direction, so this is going to move this way about the center of the gear A, which is fixed. So now the gear A is fixed. Okay. Determine the speed of gear B. So under these conditions, you need to find the speed of the gear B. If the gear A, instead of being fixed, makes 300 rpm in the clockwise direction, what will be the speed of gear B? So there are two questions actually. One, if the A is fixed, what would be the velocity of B? I mean speed of B. Second question, if the A is also rotating with 300 rpm in the clockwise direction, what will be the velocity of B? Right. So now we'll fix the given data. Right. TA, that is 36. So number of teeth on A is 36. TB is 45. Number of teeth on gear B is 45. NC is 150 rpm. So rotation of link C is 150 rpm, and that is anti-clockwise. So now this link is going to rotate like this. Okay, and this is fixed. A is fixed, so NA is going to be fixed. Question asked is, when this is fixed, what would be the speed of B? Second question, when this is moving with 300 rpm in the anti-clockwise direction, what would be the speed of B? Right. So this is a question. We'll now see how to solve this. So first we'll solve with the tabular method, and then we will solve in the algebraic method. Okay, we'll solve by both the methods. First of all, prepare the table. Right. So we know, according to given condition, arm fixed, gear A rotates through +1 revolution. Right. If, so these are if conditions. So arm is fixed means 0, but in our case arm is not fixed. Okay. Gear A making 1 rotation, so 1. Gear B, we know if gear A is making 1 rotation, gear B will be making anti-clockwise direction, that is minus TA by TB rotations. Right. Arm fixed, gear A rotates through X revolution. So if it is 1 revolution, B is making minus TA by TB. If it is X revolutions, I will multiply this with X. So that is minus X into TA by TB. Right. Arm again, if I multiply by X also, that is 0. 0 multiplied by X, that is 0. Add positive Y revolutions to all elements. So this positive Y is the movement of the arm. Right. So if the arm makes positive Y, so I will add positive Y to all 3 elements, arm C, gear A, and gear B. So total motion is, I will add everything. So plus Y for arm, gear A, that is making X motion, arm is making Y motion, so X plus Y. For gear B, arm is making plus Y motion, gear B is making minus X into TA by TB motion, so the total motion will be Y minus X into TA by TB. Right. Now we have the table. We will substitute the numbers. Right. Speed of gear B when A is fixed. Right. So when gear A is fixed. Right. Since the speed of arm is 150 rpm anti-clockwise, therefore from 4th row of the table. Right. So from this row, which is mentioned, X is making X revolution, Y is making Y revolution. Total motion is X plus Y for gear A. Right. So here, last row of the table, Y is equal to plus 150 rpm. Right. Y is equal to plus 150 rpm. Y, arm C is making 150 rpm. That is given. Right. This is a motion of arm C, and arm C is making 150 rpm. So that is this, Y is equal to 150 rpm. Also, the gear A is fixed. Therefore, so here if you see, this is for the gear A. So gear A making 1 rotation, gear A making X rotation. This is for arm C, and this is total motion of gear A. But gear A is fixed, so which is not moving at all, which does not have any movement. So X plus Y is equal to 0. Right. Why? The gear A, the motion is X plus Y. Right. So X plus Y is the motion of gear A, but it is 0. It is not making any movement. Right. So X plus Y is equal to 0. All right. So here I have x plus y is equal to 0. So from this, x is equal to minus y. You see from here, x is equal to minus y. Y I know already, that is 150. So if I substitute this 150 over here, I will have x is equal to minus y, which is equal to minus 150. So x is equal to minus y, that is y is equal to 150. So minus y is minus 150 rpm. Okay. So x is equal to minus y, which is equal to minus 150 rpm. And therefore, speed of gear B. So now we'll go here, speed of gear B. So this is gear B, right? So speed of gear B, y minus x into TA by TB. Now we know y, that is minus 150. Sorry, 150. And we know x, that is minus 150. TA given in the question, TB given in the question. We will replace everything. All right. So NB is equal to y minus x into TA by TB. Okay. The y, it's given 150. That is movement of the arm. Plus y plus here. Here I have x is equal to minus 150. Equation there is another minus. So minus into minus plus. Right. That plus x I replace by 150 into TA by TB. Number of teeth on A and number of teeth on B, that is given 36 by 45. So when I solve it, I will have 150 plus 150 into 36 by 45. So if I solve it by 9, I will have like 4 by 5. So 5 and 150 will cut by 30 into 4, 120. 150 plus 120, 270 rpm. Right. So when the B is, A is fixed, the motion or speed of B is 270 rpm anticlockwise, right? 270 rpm anticlockwise. So when you solve it, you can have in the equation, so what is the rpm coming as, right? So since the speed of arm is taken as anticlockwise, right? So this is also already given in the question, and you are replacing everything according to the equation. So whatever the plus or minus coming here will give you the direction. If 150 is anticlockwise and that is positive, 270 anticlockwise, that is also positive, right? If it is 270 and clockwise, then this answer will come in minus, right? So if you are doing correctly, replacing everything based on anticlockwise, clockwise, taking positive and negative appropriately, you will have proper answer, right? Right. The next step on this, speed of B when gear A makes 300 rpm clockwise, right? So in the previous question, A is making not any movement, that's idle. So here we'll see arm fixed and gear A rotates through a positive x revolution. So instead of this x, I will replace it by 300. Why? Because A is making a 300 rpm clockwise, right? Since the gear A makes 300 rpm clockwise, therefore from the fourth row of the table, x plus y is equal to minus 300, right? 300 rpm clockwise, okay? And we took anti-clockwise as the positive, right? So now it is given clockwise. So clockwise means we have to put negative. And this is a motion of A, right? This is a motion of A. So motion of A, it is said that, right, gear A makes 300 rpm clockwise, right? So x plus y is equal to minus 300, right? X plus y is equal to minus 300. Minus is for clockwise motion because anti-clockwise is taken in positive here, right? You see here, anti-clockwise is taken as the positive. So clockwise means definitely you have to put the negative. And 300 is the motion of the A, right? From here, I can find x is equal to minus 300 minus y, right? X is equal to minus 300 minus y. So minus 300 minus y, that is equal to minus 300. Y we know that is 150. So minus 300 minus 150, that is equal to minus 450 rpm. Okay. So now we can replace it with this equation. I know y, I know x, t and t, ta and tb are given. So I will go for this. Okay. So nb, that is number speed of b, is equal to y minus x into ta by tb. y, that is 150 rpm, right? 150 minus into x. So x is, you see, minus 450 into there is another minus. So that minus plus this minus equal to plus 450 into 36 by 45. So this 36 and this 45 are given in the numerical, right? 36 teeth for A and 45 teeth for B. When you solve this, I can solve it by like normal equation. So when you solve it by 9, I will have 4 here. Then I will have 5 here. 5 and 450, that will be like 90. 90 into 4, 360. So 360 plus 150, that is 510 rpm, right? So when now you got the answer into plus, that is 510 rpm. So plus mean anti-clockwise, right? According to what you have taken, plus you have taken as anti-clockwise. So you got your answer in plus, which means your B is rotating at anti-clockwise direction. So B is making a motion of 510 rpm in the anti-clockwise direction, right? So this is usually how we do the tabular method, right? In algebraic method, so again we'll put NA speed of gear A, NB speed of gear B, NC speed of arm C. Okay, assuming the arm C to be fixed, right? We'll assume it. Speed of gear A relative to arm C is equal to NA minus NC. We already know, right? If we are fixing C, and if the gear A is respective to gear B, then the speed is given by NA minus NC. And speed of gear B relative to arm C is equal to NB minus NC, right? Since we are assuming the arm C is fixed, right? Assuming it, all right. Since the gears A and B revolve in opposite directions, right? So we know since they are acting as a kind of simple gears, they are going to rotate in the opposite direction. So if A is rotating this way, the B is going to rotate this way, right? So we can use the formula. What is our formula saying? NB minus NC upon NA minus NC is equal to minus TA upon TB, right? So that's the formula, right? That's the formula, right? Here's the formula, right? NB minus NC upon NA minus NC equal to minus TA upon TB. This is a formula, right? So I will apply in the formula. Speed of gear B when gear A is fixed. So now this is a standard formula. Now we are going to fix whatever we need. When gear A is fixed, so which means NA is now going to be 0. And the arm rotates at 150 rpm. And now NC is going to be 150, right, in the anti-clockwise direction. So anti-clockwise means now I am taking anti-clockwise as positive, right? There is no any standard whether you have to take anti-clockwise positive or you have to take anti-clockwise negative, nothing like that. But whatever you are taking, you need to keep it up. You have to keep it up throughout the numerical, right? So now I am taking anti-clockwise as positive. So in this equation, I'm going to substitute NA and NC because NB I have to find. NB, I don't know, I have to find. NC minus 150, this minus is already there, 150 upon NA. NA is 0 because it is fixed, minus 150, right? 150 equal to minus TA upon TB, right? Equal to minus TA 36 upon TB 45, right? So 36 by 45, we know that is equal to minus 0.8. Okay, when you solve it, NB minus 150 is equal to 150 into 0.8. So that will be minus will be cancelled. 150 to 0.8, 120, right? So NB minus 150 is equal to 120. NB is equal to 150 plus 120. That will be equal to 270 rpm, right? 270 rpm. So this is for the condition of B is moving. I mean A is empty. Okay, this is for A is fixed, right? So same equation, we are going to fix whatever we wish and we are going to apply numbers whatever we know, right? Next one, speed of gear B when gear A makes 300 RPM clockwise. Right? So here we have to find the speed of gear B when the A is making a 300 RPM clockwise motion, right? So again, we will replace in this equation NB, which I have to find, minus NC, it's 150, right? 150 upon NA. NA, it's given in the question that is rotating clockwise, right? But we take anti-clockwise as positive, right? Anti-clockwise as positive. So if it is clockwise, then I have to put negative. So instead of NA, I will put minus 300 minus NC 150. Okay. So NB minus 150 is equal to minus 300 minus 150, that is minus 450, equal to minus 36 by 45. Okay. 36 by 45 is equal to minus 0.8. Right? Minus 36 by minus this 45 is equal to 0.8. Minus 300 minus 450, that is minus 450. So NB minus 150 is equal to minus 0.8 into minus 450. So minus 450 into minus 0.8 is equal to 360. Okay. So NB minus 150 is equal to 360. And therefore, NB is equal to 360 plus 150, that is equal to 510, right? So if I can write, I will write it as NB minus 150 is equal to minus 300 minus 150, that is minus 450 into minus 0.8, right? Minus 0.8, that is this 0.8. So which is equal to minus 450 into minus 0.8 minus into minus plus 450 into 0.8 equal to 360, right? So NB is equal to 360 plus 150, right? This minus 150 will come this way, so will be added 150. So I will have 510 RPM. Okay, 510 RPM. So motion of, speed of B when gear A makes 300 RPM clockwise is equal to 510 RPM anti-clockwise. You need to say the direction also, right? Since the answer is in plus, that is anti-clockwise 510 RPM. Okay. So this is how we solve the numerical in the algebraic method.